Okay, today's session, what we're going to do is cover personal protective equipment. So far, we started off by talking about the various control measures that are available to us to control the hazards, either reduce them or eliminate them. And we focused all the different types, either engineering controls, administrative controls, but frequently what the employer will have to do is utilize personal protective equipment. And so what we want to do is talk in this module about the personal protective equipment, focusing primarily on respiratory protection, but we'll also talk briefly a little bit about clothing and eye and face protection. So respiratory protection, basically some of the tasks that you might find where a respirator is needed is in maintenance or construction operations or activities where you have situations where you're disturbing materials either through some mechanical action like grinding and cutting at abrasive blasting, removing things that become aerosols after they're being removed, such as insulation or various other dust particles. We also find that when we have processes where we can generate fumes, the hot processes, work processes, where we're applying high temperatures in the work process, which causes not only smoke and aerosols, but also fumes, which are, as we know, are finely divided particles that are generated from various processes. Some of the examples here we have where we can generate fumes and particulates are soldering and brazing, welding operations, smelting operations are very frequently where you can do that. You can also have situations in processing of photographic materials, printing, where you can use some acid and alkaline types of materials where various particulates could be generated. Oftentimes workers will use solvents to clean parts, and so we can get into generating gases and vapors in that cleaning processes. And then finally, performing tests, such as where we're spraying a product, either in the form of cleaning or spray painting or coating materials, where we cause a liquid material to become aerosolized and vaporized and create potential exposures. Other processes might be where we are atomizing or spraying of the materials. We have processes where combustion takes place. And in that combustion processes, we can liberate gases and particulate matter. Oftentimes, when we're working with chemicals, we have chemical reactions go on. And so you have situations where you not only have the individual potential exposure to the individual chemical, but you also have the potential of the byproduct of those chemical reaction and what could be generated and cause exposures. And some of those byproducts might be a situation where you would want to wear respiratory protection. Sometimes in certain types of industries, employees have the potential coming in contact with materials that are carcinogen, things that will cause cancer, or things that are sensitizers where they can do cellular damage in the body and cause sensitization to that chemical product and resulting in an adverse health response as a result of that sensitization. In some cases, we have workers work in jobs where the materials that are being handling are going to be considered highly toxic. And so because of the toxic nature of those materials, the workers might be required to wear respirators. Some of the other situations where we can get into respirator use would be like if we're entering a confined space and we have the potential of not having sufficient amount of oxygen present, or where we might have dangerous atmospheres that are created by materials that are present inside of that atmosphere, which would require our employees who are going to enter those spaces to wear appropriate respiratory protection. A real obvious use of respirators is if you're in the emergency response or firefighting industries, if you're in a situation where you're responding to chemical spills. We use them as backup systems. For example, if we have a toxic material present in a container, and if that container leaked, it would create a toxic atmosphere. Well, we would use escape type of respirators for the workers to get out of that area. Asbestos abatement. There's a lot of employers out there that are involved in the industry of removing asbestos. And during the course of the removal of those materials, their employees be required to wear appropriate respiratory protection. And even you, as environmental health and safety personnel, working on jobs that are involved in your daily task, you could be required to utilize respiratory protection because you're working in those areas where those dangerous situations might be present. So some of the things that would indicate to us that where we might have a need to wear respirators is first, if we have employees complaining about odors or conditions present that it bothers them, it causes them headaches or eye irritation and so on. And based on those employee complaints, it could justify the need to look into utilizing respiratory protection to protect the employees. In some cases, we may actually have symptoms that the employees are demonstrating, and those could be irritated eyes or coughing and those kind of health responses from exposure to toxic materials, acutely toxic materials. And then finally, we could have situations where we're actually doing medical monitoring. A good example of this would be if we had workers who were being exposed to lead and we did medical screening and tested their blood and urine, and we found high levels of lead in the blood system. That would certainly be a justification then that there's an exposure going on and employees need to wear respirators. So respirators are a vital component of our personal protection that we offer to workers, and we want to go in and talk a little bit about respirators and things that you should know and understand about respirators. First, respirators that are used in the work environment need to be approved to be used in the work environment to protect the workers. And the reason I say that, there are respirators out there that you can go into a store that are available to workers, but they haven't been tested and certified to ensure that they meet certain levels of criteria as far as being able to afford or offer the level of protection that has been dictated. And the group that does the testing and certifying of respirators is NIOSH, the National Institute of Occupational Safety and Health. At one time, both NIOSH and MSHA, the Mine Safety and Health Administration, used to jointly do the testing and certification, but this is an area where government realized that was a redundancy, and so they, several years ago, MSHA recognized that this is really an activity that should fall upon one agency, and that appropriate agency to do that is NIOSH. So NIOSH, every respirator needs to be tested and certified by NIOSH, and they have established protocols as far as what standard the respirator has to meet as far as design and function. And then so when NIOSH goes and conducts its certification and testing, what they'll do is they'll conduct it on a specific type, a brand of respirator, and all the parts that go along with that particular brand of respirator. And when we look at the components of a respirator, we're going to see that they'll have cartridges and harnesses and everything that go with the respirator. And there's multiple brands. You can have MSA, you can have North or Wilson, or so there's a dozen different brands of respirators. Well, the parts on those respirators cannot be interchangeable. So if you're going to use a North brand face piece, then you've got to use North brand cartridges to go onto that respirator. And on the cartridges, you will see there is a certification number, and that's referred to as the TC number. TC simply stands for tested and certified. So on that cartridge, you'll see the TC number listed by NIOSH that verifies that the respirator has been tested and meets the certification requirements that NIOSH has established. Well, there's two types of respirators that, general categories of respirators that are available to workers. The first is air purifying respirators, is which we'll talk about right now. The second is air supplied respirators. Air purifying respirators are basically those respirators that, when worn properly, are going to purify the air that passes through the respirator. And that respirator can be in the form of a half mask, which covers only a half of the face, basically the area above the nose and the mouth. Or you can have a full face mask, and that full face is where it covers not only the face and mouth, but also the eyes. And generally speaking, when we go to select a respirator, if we need to provide eye protection from chemical exposures and so on, then it's probably best to select a full face type of respirator that provides you the eye protection that you need. Now, air purifying respirators, another component of them, of the entire respirator, is going to be the cartridges. And the cartridges are those devices that are going to mechanically filter out the contaminants that are present in the air. Now, depending on what you're trying to filter out will be dependent on what type of cartridge you're going to select. Now, cartridges are color-coded, and the color is representative of the type of material that that particular cartridge will filter out. And that color coding has been established by OSHA. So every brand of respirator has to use the same color coding system for their cartridges. In a moment here, we'll look at the color codes and what they mean to us. Now, another type of air purifying respirator that's commonly used is referred to as a powered air purifying respirator. And the biggest difference between the powered air purifying respirator and the half mask full face type of air purifying respirators is that there's a motor actually involved that causes air to be forced through that filter system and pumped into the mask. Either the mask could be a half mask, but more commonly as a full face mask. So powered air purifying respirators. And one of the benefits of a powered air purifying respirator is that's going to give you a higher level of detection or protection, which we'll talk about in a little bit. As I mentioned, the other type of respirator category that we have is what we refer to as an air supplied respirator. Now, in an air supplied respirator, basically what you're going to do is have some source that's going to provide you with clean, fresh air to breathe. Now, that source could be in the form of a tank, much like you would see in firefighters wear in self-contained breathing apparatus. You have a tank which contains breathable air, and the quantity of breathable air will last either 15 minutes, 30 minutes, or 45 or 60 minutes, depending on the size, the capacity of the tank. Or we have an air-supplied respirator, an air-line respirator, where we have a generator that's going out and gathering up fresh air, breathable air, and putting it through hoses, and regulator systems into a mask and delivering into that mask breathable air. Both of those are air supplied versus air purifying. We're providing or supplying the fresh air. So those are two general categories, and we'll see pictures of those, both of those types of respirators in just a moment. Well, OSHA has a standard that covers respirators. It's found in 29 CFR 1910.134, and that's our respirator standard. And basically, the four primary elements of that standard requires you to have a respirator protection program if you are going to use respirators. And first, you must have a written program that outlines your program, how it will be implemented, who's responsible, what are the responsibilities, how are you going to do training, fit testing, and so on. The second component of your respirator program is you need to have medical certification of the workers who are going to be wearing these respirators. We need to make sure that the workers who are going to utilize the respirators are capable of wearing a respirator without putting them in jeopardy, health-wise or safety-wise. Sometimes the respirators that people wear will put a body burden on your breathing, which can affect your heart rate. Well, we want to make sure that the worker does not have some kind of medical condition that wearing of that respirator would put them in any kind of jeopardy. So you must have a medical exam. A physician needs to conduct it, and you have to have written documentation that essentially the physician who conducts it states that the particular individual is medically fit and capable of wearing a respirator without putting their health in jeopardy. Then once we have defined, we've gone out and conducted assessment. We've done air monitoring to show that respirators are needed. We've established our written program. We've selected the respirators that are going to be used. Now the next thing we need to do is train those workers in how to wear the respirator properly. And so we have to have employee training on the training subjects need to explain to them what the respirator will protect against, what it won't protect against, how it's to be used, how it's to be worn, what's the proper way to wear it, what's the proper way to fit it when you put it on, how do you do fit testing. Every time you put it on, how do you do a positive and a negative fit test? We train them what to do as far as maintaining the respirator. If you lose parts to it or something becomes broken, how you go about replacing the parts. We need to teach the employee of how to clean it and store it when it's not in use to make sure that it is maintained in a sanitary condition and a good working order condition. So all of those things we cover in an employee worker training class on personal protection and respirators. Then to supplement that training, we conduct fit testing, and there's various types of fit testing that can be done. The first type is the type of fit testing that's done any and every time a worker puts the mask on, and it's referred to as a positive and a negative fit test. Once you don the mask or put it on, what you want to do is cover the cartridges where air comes in, cover them with your hands to get a tight seal, and breathe in on the mask. If you've got the cartridges covered and you have a good fit, that mask should feel like it's collapsing around your face. The second type, that's a negative fit test. The second type of fit test is a positive fit test, where you would cover the exhalation valve with the palm of your hand, again sealing that port off, and then gently blowing out into the respirator, and you should feel like the respirator is puffing out and air is filling the respirator. That would indicate to you that you've got a good seal. So that is a positive and a negative fit test. The other type of fit test Then we get into our quantitative fit test and qualitative fit test. And I think we talk about each of those a little bit later here. So if we looked at what's required in your written program, if you're going to develop a written program, the first is a section that talks about how you're going to go about selection of the respirators. Usually this is supported by air sampling that you've already conducted that demonstrates what the contaminants are and what level the contaminants are that are present in your workplace that justifies the need for the use of a respirator. And that would be covered in your selection process. The second section would cover how are you going to go about doing the training, what your work mission is and duration, your personal use factors, that when you're wearing a respirator, what are those factors that you need to be aware of? You'll talk about what kind of fit testing you're going to do. First of all, whether it's going to be a qualitative fit test or quantitative fit test. And you also talk about how to conduct the positive and negative fit test every time you don the mask. Then your program's going to talk about the proper way to put the respirator on or donning the respirator and how to wear it in use to make sure that it is offering you adequate protection, and then how to remove the respirator or doffing the respirator. And then what you need to do personally to inspect the respirator to make sure that it is in good working order, that it's not missing any parts, it's not damaged in any way. And then you'll have a section in your written program that talks about storage of it, how you'll store it in a sanitary condition, in a sanitary location where it's not going to be physically damaged or contaminated. And then finally, what to do with respect to maintenance of the respirator. If you do find that the respirator is missing some parts or you need replacement cartridges or any of those types of things, then that information on how you go about doing that is covered in your maintenance section of your respirator. Well, we talked about air purifying respirators. There are certain conditions where you cannot wear a air purifying respirator, and this is usually spelled out in your respirator program. And the first one is where you have an oxygen deficient environment. Obviously, we can't put respirators on workers for air purifying if we don't have sufficient amount of oxygen present in the air to support life. So if we're in an oxygen deficient environment, then we can't use air purifying respirators. We must use air supplied respirators. A second area would be those areas where the environment is immediately dangerous to life and health. That the contaminant or the level of concentration of the contaminant that's present could be at one of those levels that if the workers were wearing a purifying respirator and, for example, the respirator was leaking or became damaged or the worker had to remove it in some way, that environment they would be present in would be dangerous to their life and health without that respirator. Well, in those kind of situations, you cannot wear an air purifying respirator. Again, you must wear the air supplied. A third scenario would be entry into an unventilated or a confined space area where the exposure conditions have not been fully characterized. So if we got for example, a tank or a vault, underground vault where workers have to go down into, we don't know exactly what might be present, then for workers to go in and enter that area, we have to assume the worst case scenario, and those the workers must wear an air supplied respirator. And then finally, if we have a situation in any kind of environment where we don't know what the hazard is and it hasn't been documented as far as what the concentration of a dangerous material is, then you need to always err on the cautious side. Wear an air supplied respirator until you get enough information that you can truly characterize what the air is and what the concentrations are that are present of that contaminant. And then you can downgrade into an air supplied. Again, when we get into contaminant concentrations which are unknown or exceed the maximum use concentrations, now respirators will, depending on whether it's a half mask or a full face mask or a powered air purifying respirator, they will have a protection factor value assigned to it. So we need to look at what is our concentration in our environment that we're going to put the workers in, and what are the protection factors of the respirator, and make sure that the respirator protection factor is adequate to make sure we don't exceed the maximum use concentration for that respirator. So in other words, if I've got a respirator that has a protection factor of 10, and essentially what that means is that it's going to be okay to use that respirator up to 10 times the PEL or TLV for the compound we're going to be protecting against. So let's say it's a chemical substance that has a TLV of 10 parts per million. Essentially, if I've got a protection factor of 10, what it means is I can wear that respirator up to a level of 100 parts per million of that contaminant. And so that's where the protection factor is. It's a level of protection above the PEL that we can wear that respirator. Another area where we cannot use air purifying respirators is when we have a situation where the chemical that we're going to protect against doesn't have adequate warning signs to tell us or to be able to detect the chemical that's present. A good example of this would be mercury. For mercury, there is no odor for mercury. It has no odor to it. And so we could be well above the acceptable exposure limit for mercury and never know it because we couldn't smell it. Some respirators can manufacture or will manufacture a signaling device for those types of chemicals that don't have good warning properties and that it will be an end of service life indicator. And so that's essentially a warning signal that tells you if the absorbent in that cartridge has been used up, and you could potentially start having breakthrough come through that cartridge. That indicator would warn you that it's time to change out your cartridges because you could be overexposed. But essentially, if a cartridge doesn't have an end of service life indicator on it, and the chemicals that you're protecting yourself against don't have good warning properties, then you cannot use air purifying respirators for the protection. Another area where air purifying respirators are not effective are in situations where you're going to have very high relative humidity. And the reason for that is that because the moisture in air can cause those chemicals to travel through the absorbing material that's in those cartridges and therefore not appropriately filter out the contaminant. So going back again on the respirator fit testing, we've talked about the positive pressure. The other types of fit test we have from a qualitative fit testing, we have what we refer to as an irritant smoke. And that's basically what we do is we get a tent, a little clear plastic tent. We put it, the worker, inside of the tent enclosure, wearing the respirator, and we inject a compound that is basically an irritant. And so if there was a leak in the cartridge or the respirator fit, that irritant smoke would enter into the respirator and it would cause the worker to have a response of basically just a cough response. It's not anything that's going to cause any harm to them. but it will definitely let you know as the tester that they don't have a good seal on that respirator and it's not filtering out the contaminant. Another type of qualitative fit test is what we refer to as isoamyl acetate, or a testing, or it smells like isoamyl acetate. It smells like banana oil, so it smells like bananas. So you can use this vapor from this isoamyl acetate the same way you'd use an irritant smoke inside a test chamber, and ask the employee that you're testing, do they detect the smell of banana oil? One of the downsides of this type of testing is that some people are not sensitive to the smell of banana oil. And secondly is that they'll, just to be able to get through the test, they won't truthfully respond whether they can smell it or not. They'll tell you, no, I don't smell anything, when in fact they may have a poor fit on the respirator and do smell it, but they want to get through the testing of it. And then we have another thing that's referred to as the saccharin test, and this is basically we spray an aerosol of a saccharin sweetener into the air, and if they can detect the sweetness, that is an indicator that there's a leak. Basically, of all of these, irritant smoke is probably the most common one used, because it's nearly impossible for anyone to fake the results of this testing. If the respirator is leaking, the irritant smoke will let you know. Now, during the testing, qualitative fit testing of the respirator, OSHA requires that the worker read a passage, and that's referred to as the rainbow passage. And the reason being is that it puts the worker's facial muscles through pretty much typical distortion, if you will, for when they're talking and conversing, and we want them to do that because we want to find out when they're talking or communicating with fellow workers out in the work environment, are they still getting an adequate seal on their respirator to ensure that they're not being exposed to the contaminant. The other types of fit testing that we have is what is referred to as quantitative fit testing. Now, quantitative fit testing at one time was too expensive to perform. People had to come into test chambers that were in buildings, and they would have to use pretty elaborate gas chromatograph equipment to measure concentrations inside of masks and put people in these test chambers. It was really a situation where it wasn't cost effective to do quantitative fit testing. However, with new technology, the last two decades, they have come out with some what we would refer to as portable quantitative fit testing machines that make it easier for us to do quantitative fit testing. We can even go out into the field or into the workshops and be able to do it. The first type is that I described earlier was the test chamber, which now with the other two, next two units that are listed, we don't really see much use of the test chamber technology. But the first one of the portable units is called the port-account fit tester. And essentially what it does is you generate an aerosol, again, in a tented area to contain the aerosol. And you have probes going into the mouthpiece or face piece that are connected to a piece of equipment. And what the probes are going to do is measure the particles that enter into the respirator. And if the particles exceed a certain level that is programmed in your instrument, then that's an indication that you've got leakage and you don't have an adequate fit, and you need to do adjustment to the respirator to make sure to improve your fit until you reach a level where it has been established to be an acceptable fit. So we use particle counting to do that technique. The second technique is where we use a pressure differential for the respirator. And essentially what we do is, again, we change the cartridge out on the respirator the worker is going to wear, and we put on these other test cartridges. And what we can do is have the worker hold their breath, and we close off a breathing port for that respirator, and then there's tubing that's connected into the respirator that sucks air from inside that respirator. And if we got a good fit, then that respirator, by sucking that air from inside of it, will collapse on the worker. And so we can measure that pressure differential, and again, electronically within the equipment, can determine whether we have an adequate fit or not. And if we don't, then we make adjustments to the respirator until we do get that adequate fit. So both of those are portable, recognized quantitative fit tests by OSHA, and they're very affordable now and easy to use. Well, as I'd mentioned, respirators will have protection factors assigned to them. And the protection factor just tells us is how much protection, or the degree of protection that that particular respirator will give to the worker. For OSHA has established these levels of protection. For a half-mask respirator, the level of protection is 10. So theoretically, we can wear that respirator up to 10 times the PEL or the TLV for the particular chemical that we're interested in. For a full-face respirator, the protection factor is 50. For a powered air purifying respirator, it's 100. For a Type C pressure demand respirator, which are your airline respirators, you have a protection factor of 1,000. And for self-contained breathing apparatus respirators, the protection factor assigned is greater than 10,000. So you can see that we get greater levels of protection with the more sophistication of the respirator. A full face, the reason we get 5 times the protection greater than the half mask, we get 50, a protection factor of 50, is because it's easier to seal around the circumference of the face than it is for a half mask, where you're trying to seal around just the nose area. So again, the powered air purifying respirator, the reason we get a greater protection factor is we're actually dumping air inside the mask. So if we do have a leak, it's going to escape outward, and contaminants are not going to enter into the mask. Well, let's take a look at some respirators. Here's an example of a half-mask respirator. You can see here we've got a harness, a cartridge that covers the mask. This particular one is a North brand. It costs roughly, probably today's market, more like $30. But it'll have a harness, and it'll have the respirator body of it, and inside of it, it will have inhalation valves that are very important to the respirator. And they have little valve covers, again, that are an important component. And then you'll have an exhalation valve. That's where the exhaled air is going to leave the respirator. And it'll have a cap and a cover. And then it's going to have cartridges. And so when you use a respirator, a particular brand of respirator, you must use the same brand of cartridge. So here, if we've got the North brand respirator, we need to make sure that we use the North brand cartridge. Now, I'd mentioned that OSHA has different cartridge color coding designation for what the cartridge will protect against. Here's a list from the OSHA 1910-134 Table 1, I1 actually, and it'll tell you what the color code and what it'll protect against is. A white cartridge is going to be for acid gases. Black is organic vapor. The white one, again, is the acid gas organic vapor combo. You can get in combos. And then the orange is going to be an acid gas, organic vapor, and ammonia. The magenta is going to be asbestos dust and radionuclides. Green is going to be for ammonia. Blue is carbon monoxide. And then kind of the orangish color is going to be a multi-protective respirator that will protect against all of those substances above. Well, we use the term HEPA a lot. In HEPA cartridges, it's important we understand what a HEPA cartridge is. HEPA stands for the High Efficiency Particulate Air Filter. And essentially this is a filter, and in the case of the respirator, it's a cartridge filter that is capable of filtering out 99.97% of particulates at 0.3 microns in size. So anything that's 0.3 microns in size or greater, this particular cartridge will filter out 99.97% of that contaminant. So you can see it's a very efficient type of respirator. Again, this is the example of the HEPA cartridge. Here's a HEPA cartridge, combined acid if we want a multi-stack. The black cartridge is going to be the organic vapor. We got the green cartridges, which are ammonia. Now, anytime, one of the things that when we get into stacking of these cartridges, it allows us to protect the workers against multiple types of contaminant. Some of the disadvantages are the more you stack on here, the harder it is for the worker to breathe. And secondly, the amount of absorbent material in the cartridges is going to be less than a cartridge that's singly designated just for that contaminant. And because you have less cartridge absorbent material, it's most likely that cartridge is going to be used up faster, and you're going to have to replace those cartridges. Again, we've got multiple brands of respirators, and in each brand or style, we have different styles of respirators that you can have. And here's just an example of 3 different styles. All these respirators are made by the same manufacturer. In this case, it's 3M. But you can see they have different configurations depending on cost, as well as depending on what you're using it for. Now, here's an example of a full face respirator. And again, when we want to achieve eye protection, we have a tendency to select a full face mask because it gives us not only our breathing protection, but it protects us against splashing of the chemicals in our eye. Again, you can see here's an example of a North full face mask. And this one here is a powered air purifying respirator where you get into, you can see here, there's a little battery packed over here. This is the battery that's going to cause air from this motor to be drawn through this cartridge. And it's going to, that air that's being filtered out in this cartridge is then going to be pumped into this mask. But it's all driven by this battery that operates this motor. So a PAPR is going to give us a higher level of protection, but that's what they look like. So the components of that PAPR, you're going to have a mask, you're going to have some cord, you're going to have a motor and a fan and a cartridge, and then your battery pack. And there are different brands who manufacture PAPRs. Here's a type of PAPR that's a hooded type of protection versus the face-fitting type. You put this whole hood on, and you got air that's being dumped into the hood space, and it's clean breathing air that's been purified. Here's an example of a Type C pressure demand respirator, where in this case we're dumping fresh air through this regulator that's on this mask into the mask. And on this particular respirator, these cartridges are for escape purposes. So if our air supply for some reason was cut off, we have these cartridges placed on the mask that will give us sufficient time to get out of the area. So we've got a regulator with the airline and the egress cartridges for the escape. Well, we talked about cleaning of respirators. They need to be properly maintained and cleaned. Typically, you want to stay away from using alcohol. Alcohol will have a tendency to dry up the rubber components of the respirators. And as a result of that, you'll have cracking and damage to the respirator. There are mild detergent soaps. You can use just a mild household detergent to clean it with warm water. Or you've got, for example, here is a MSA manufactures a mild detergent soap you can mix in a bucket of water and use it to clean. But anything that's very mild detergent to clean the respirator is best. So if we take a look at the supplied air respirator, basically what you're going to have is some source of breathable air. In this case, it's in this tank and cylinder. And that cylinder then will be connected to a regulator, and that regulator eventually connected to the mask facepiece, where the good, clean, breathable air is pumped from this canister or cartridge into the mask. Now these tanks will hold anywhere, depending on the size and capacity, 15 minutes to 30 minutes to 45 an hour. I've never seen any tank going greater than a 1 hour capacity. It just becomes too bulky of a device for workers to wear. Anything greater than that. But this is the type of tank that, or respiratory system that you would find your emergency responders, policemen, and so on utilizing. Now, going back on here, a tank is one means of it. The other is a supplied air respirator, and what we're going to have with a supplied air, or an airline respirator, I mean, is you're going to have a generator that's going to generate the fresh air. And so it's going to be piped, usually from a compressor of some type, through your tubing, which is your airline, into the mask, and the mask itself may have a regulator. Now, it's critically important that, number one, you place this air compressor in an area where it's going to draw in clean, fresh air. And OSHA requires that those generators have certain kind of monitoring and filtering devices on them to ensure that the air that's being delivered to the user of this mask is clean. I worked on a case as an expert witness in Chicago where a generator was being used, and it was an oil lubricated generator, and those generators are supposed to have oxygen monitors and carbon monoxide monitors on the device. So if it started overheating and generating carbon monoxide, the carbon monoxide wouldn't be drawn into the airline system and delivered to the user. Well, this particular user had this generator located on a ground level, and he had air lines that he could go down into a basement, and he was performing work in a basement area, spraying some chemical compounds. Well, the particular generator that was generating the breathable air was an oil lubricated. It malfunctioned, and so carbon monoxide got drawn into that generator, and unbeknownst to the worker, there was nobody topside by the generator. It was just the worker using it, and he was in the basement. He didn't know that this malfunction was taking place, and he was overcome by carbon monoxide poisoning and died. So it's very important that you make sure that whenever you're using supplied air, that you have a generator that's going to provide you with clean, breathable air in accordance with the OSHA regulations. Here's an example. We talked about irritant smoke. This is an example of a device that generates the irritant smoke inside that tube. There's a stannate chloride material that when it's aspirated out into the air, if you breathe it, it will cause you to give a cough. Well, some of the other types of personal protective equipment that we frequently have workers utilize are going to be in the forms of gloves to protect the hands and clothing to protect the bodies. And again, when we talk about gloves and body protection, these products can be made from various materials, and the type of material it's made of will determine the type of protection it will provide to the worker. Certain chemicals will break through certain materials that are used to make the personal protective equipment. So if I'm using a nitrile latex glove, some chemicals are going to penetrate it much easier than it would be if I was using a natural rubber glove or a glove that offers more protection against that particular chemical material. And what we look for when we're going about selecting the gloves and the clothing is what type of breakthrough time does the particular material that we're using have. And manufacturers can provide you, through studies that they've conducted, they will give you the permeation or breakthrough time that a chemical has on certain types of products. And so you can find out, does it take 30 minutes or 60 minutes or 2 hours or 4 hours for a particular chemical to break through this material. Chemicals will break through just about any material. It's just a matter of time. So what we want to do is we want to make sure that we select a particular glove or clothing material that's going to afford us the longest amount of time before breakthrough does occur. Again, on clothing, we can get into reusable clothing or we can get into disposable clothing. And there's a variety of different types of disposable clothing, and the level of protection that disposable clothing will have based on how the clothing is made and what materials it's made of. Typically what we see is Tyvek clothing. Some of it can be chemical resistant Tyvek, some of it's breathable. Depending again whether we're dealing with chemical liquids or aerosol particles would depend which type of material we would have. I think your book goes into discussing both gloves and protective clothing and the types of materials that are utilized to make this clothing. One of the things we always got to remember also is when we put workers in any protective equipment that it is going to put a body burden, a stress, a strain on the body. We need to be cognizant of that factor, especially when it comes to when workers have to work in hot environments. We put this personal protective clothing on, and it just exemplifies or increases the magnitude of the heat stress condition. And so we have to be aware of that and watch out for workers and sometimes select clothing that is going to take into effect those heat stress conditions. So when we talk about heat stress, we'll talk about how we deal with those types of situations. So just to give you an example, a listing of the different clothing, we've got full body coveralls, could be either disposable or reusable, could be breathable or non-breathable. We got gloves, you've got boots, hard hats, eye protection. This slide we use as in our asbestos talks, so we talk about if you're wearing personal protective equipment while you're working with asbestos or any kind of chemical, once it becomes contaminated, it has to be disposed of as a contaminated material, just like the waste material. Here's just some pictures of a Tyvek. This is a spunbound olefin. This is more of a breathable type of thing. Again, we utilize these slides in a lot of the asbestos training. That's why you see references to asbestos. Here's an example of some latex gloves, rubber gloves, and there's various types of rubber materials that can be used. Nitrile gloves, butyl rubber, boots. We get into boots and steel toes and shanks, where you may be in a situation where we have to wear those types of foot protection. When you do that, you want to make sure that you get treads that are going to be easily cleaned. Oftentimes we'll use these types of protection on our hazardous waste sites. The environmental people, you as well, at some point may have a need to go out and work on these sites during cleanups, where you have to wear this protection in accordance with 1910-120 standard. You can see here's a picture of a boot that has a poor tread, hard to clean. And when we talk about the 1910-120 and personal protection, there's a reference to levels of protection, level A, B, C, and D. And essentially what we've got is the level A protection is the maximum level of protection. It's a totally fully encapsulated suit with an air-supplied respirator. Level B protection is still using an air-supplied respirator, like in a chemical-resistant suit, not a totally encapsulated suit. And level C would be where we're using an air-purifying respirator, not an air-supplied. We would still use a chemical-resistant suit. And level D is basically no respirator, but we might have gloves, hard hats, and glasses, and so on. So again, here's just a rundown. Level A protection, where we've totally encapsulated with a positive pressure air supplied respirator. Level B, again, positive pressure respirator with a chemical resistant suit. Level C is where we get into an air purifying respirator. And level D is no respirator. So that ends our personal protective equipment. Again, you'll have sections in the book that cover the subject material. And we have some, I think there is a project on personal protective equipment as well. So we're going to take just a short break. Our next session that we're going to have is going to deal with indoor air quality. So when we come back, we'll record that section.